In this episode, we shift from storage and administrative pathways to the platforms that many cloud applications actually run on, because modern cloud environments often rely on managed application services rather than self-managed servers. An application service platform is a managed environment where you deploy code and the platform handles a lot of the underlying infrastructure, such as scaling, runtime management, and some aspects of networking. These platforms can make teams faster and reduce certain operational burdens, but they also introduce a new kind of security challenge. You are configuring a powerful service that comes with many features, and every feature is a potential security decision. A hardened baseline configuration is the set of default settings you choose so that when a team deploys an application service, it starts in a secure posture instead of a permissive posture. Baselines matter because most incidents are not caused by one clever attacker trick. They are caused by predictable misconfigurations that repeat across teams and projects. The beginner goal is to understand what a hardened baseline is, why platforms need them, what kinds of settings usually matter, and how baselines reduce risk without requiring every developer to become a security expert. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful way to think about managed application platforms is that they are a bundle of capabilities, and security comes from deciding which capabilities are enabled and how they are constrained. These platforms often include identity integration, network exposure options, data access integrations, logging features, and runtime controls. They can connect your application to storage, databases, and messaging systems, and they can expose your application to users through public endpoints. That flexibility is valuable, but it also means there are many ways to accidentally create an overly broad trust relationship, such as giving the application more permissions than it needs or exposing it broadly without strong access control. A hardened baseline is your starting point that says, before you customize anything, this is the safe minimum posture we expect. It reduces the number of risky defaults that can slip into production simply because someone did not know a setting existed. Beginners should notice that this is not about locking everything down so tightly that nothing works. It is about choosing defaults that make unsafe outcomes less likely and making teams opt into risky exposure only when they have a clear reason. One of the most important baseline areas is identity and permissions, because application platforms often run with an identity that can access other cloud resources. If that identity has broad permissions, a compromise of the application can become a compromise of the environment. Hardened baselines typically start by ensuring the application identity has least privilege, meaning it can access only the specific resources it needs, and only with the actions it needs, such as read-only access where possible. They also avoid shared identities, because shared identities reduce accountability and make it harder to detect misuse. Another baseline habit is to separate identities by environment, so that a development deployment cannot automatically access production data. This reduces the chance that a mistake in a lower environment becomes a production data exposure. For beginners, the key idea is that an application platform is not just code hosting. It is an identity in your cloud that can do things, and you want that identity's powers to be limited by default. Network exposure is another baseline area because many application services can be deployed as publicly reachable by default. Public reachability is sometimes necessary, but it should be an intentional choice, not the accidental result of a default setting. A hardened baseline often sets the expectation that internal services remain internal unless there is a documented need for public access. It also encourages scoping access by network boundaries, such as limiting which networks can reach administrative endpoints or private APIs, and separating user-facing traffic from internal management traffic. Even when public access is required, baselines can include expectations like enforcing encryption in transit, limiting legacy insecure protocol support, and ensuring that only the necessary ports and paths are exposed. Beginners should remember that reachability is part of the security posture, because if a service is reachable from anywhere, attackers can test it from anywhere. A baseline that starts private or starts scoped reduces the number of services that become internet-facing by accident. Configuration hardening also includes runtime settings that affect how the application behaves under attack or failure. While we avoid tool-specific commands, we can still talk about the concepts that commonly matter. For example, baselines often include secure defaults for error handling so that detailed internal errors are not exposed to users, because verbose errors can leak sensitive information about the system. They often include resource limits and scaling controls that reduce the chance of cost and availability attacks, where an attacker generates traffic to drive resource consumption. They can include restrictions on outbound connectivity, because an application that can connect to anything can be used as a pivot point for exfiltration or lateral movement. They also often include secure handling of sensitive configuration data, so that secrets are not embedded directly in application code or exposed in logs. Beginners should see that baseline hardening is not a single checkbox. It is a collection of choices that reduce common attack opportunities. Logging and observability are critical baseline components because managed platforms can generate useful telemetry, but only if you enable it and retain it. A hardened baseline typically ensures that application logs, access logs, and platform events are captured consistently, retained for a meaningful period, and protected from tampering. It also helps to ensure the logs include the right context, such as identity information, request characteristics, and outcome codes, so they can support investigations. Observability also includes monitoring for anomalies, such as unexpected traffic spikes, unusual error rates, and unusual administrative changes. The reason this belongs in a baseline is that if you wait until an incident to discover logging was not enabled, you have already lost valuable evidence. For beginners, the takeaway is that security is not only about blocking, it is also about seeing, and the ability to see must be built in from the start. A hardened baseline treats logs as part of the platform's security boundary, not as optional troubleshooting output. Another baseline area is change control and configuration drift prevention, because platforms evolve and teams change settings over time. A service might start secure, but then a developer enables a convenience feature for testing and forgets to turn it off. Or a deployment template might change, and suddenly new services are created with a more permissive posture. Hardened baselines are most effective when they are expressed as repeatable standards that can be checked, not just as one-time setup guidance. This means you want a way to know whether new deployments match the baseline and whether existing deployments have drifted away from it. Drift is dangerous because it is silent, and silent changes are how misconfigurations become headlines. Baselines also need ownership, because if nobody owns the baseline, it will not be updated as the platform adds new capabilities. Beginners should understand that baseline hardening is a living practice, because cloud platforms change and the baseline must keep pace. It is also important to consider how baselines support developer velocity, because if baselines are too rigid or difficult to use, teams will bypass them. A practical baseline provides secure defaults while leaving room for controlled exceptions, and it makes those exceptions deliberate and visible. For example, if a team truly needs public exposure for a user-facing service, the baseline should guide how to do that safely, rather than forcing them to invent a workaround. If a team needs access to a sensitive dataset, the baseline should make it easy to request the minimal permissions rather than encouraging broad access. A baseline that is aligned with how teams actually build and deploy applications will be adopted, and adoption is the foundation of real security improvement. Beginners should see that the best baseline is one that reduces cognitive load, meaning it saves teams from having to remember every security setting because the secure posture is already in place. The baseline becomes a safety net that catches common mistakes. A useful way to summarize the value of hardened baselines is to think in terms of reducing variance. In a cloud environment with many teams, every service configured differently becomes a unique security problem, and unique problems are hard to monitor and hard to secure consistently. Baselines reduce variance by making secure configuration consistent across services, which simplifies detection and response. When services are consistently configured, you can build better access patterns, better anomaly detection, and better incident response playbooks. You also reduce the chance that one team unknowingly deploys a service with a dangerously permissive posture because they copied an old example or misunderstood a setting. For beginners, this is an important systems thinking lesson. Security improves when you make the safe choice the default choice, not when you rely on each individual to remember all the right choices every time. When you put it all together, securing cloud application service platforms with hardened baseline configurations is about engineering a secure starting point that scales across teams and stays stable over time. You focus on identity and least privilege so that an application compromise does not automatically become broad cloud compromise. You make network exposure an intentional choice and scope reachability so services do not become publicly reachable by accident. You harden runtime behaviors to reduce information leakage, limit resource abuse, and constrain outbound paths that attackers can misuse. You bake in logging and observability so detection and investigation are possible from day one. You plan for drift and change control so secure posture does not erode quietly as teams move fast. And you design baselines that support operations and development rather than fighting them, because adoption is what turns a baseline into real risk reduction. The big picture is that hardened baselines turn a complex platform into a consistent, defensible environment where secure behavior is normal, misconfigurations are rarer, and the inevitable changes of cloud life are less likely to produce the kind of weaknesses that attackers exploit first.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.